our last team up is DevBook. So DevBook has a really cool take on software engineering live with people in a collaborative environment. Yeah, take it away, DevBook.
Good afternoon, everyone. We are Jang, Connor, Fred, and Ben. And we are the team behind your new favorite on-the-go coding environment, DevBook. DevBook is collaborative coding notebook inspired by REPL and notebooks like Beaker and RunKit. Let's say Dumbledore is a teacher who wants to demonstrate how set timeout works in a lecture. As a user, Dumbledore can create a notebook in which he can write and run set timeout functions in snippets. He can also share this notebook with his students, allowing everyone to contribute. Dumbledore clicks play and everyone sees the results. And here he allows Harry to contribute. Harry clicks play and they both get the result. By allowing the group to work on the same notebook in real time, Dumbledore can run his lecture interactively. And now Connor is going to talk about how this real-time interaction is possible.
Thank you, Jang. We could have used separate database, socket, and other APIs in order to provide these automatic updates. However, Firestore combines all of these. We use Firestore as a single source of truth for data in our app. It combines everything from code snippets to their results to which users have access to certain notebooks. On top of this, we used Firestore in order to provide authentication and privacy. Additionally, being a real-time database, Firestore provides an update each time the database is altered. This allows our users to see their friends' updates in real time, as well as to not have to worry about manually updating their database. Firestore providing the user authentication and privacy means that not even a pesky Alohomora charm will unlock your user data. However, Firestore cannot prevent users from running malicious code. Here's Fred with how we solve this issue.
Thank you, Connor. So an option to run JavaScript code is the eval function, but the eval function has a web security vulnerability, as it is vulnerable to a cross-site scripting attack. Therefore, to avoid this vulnerability, we chose to use Docker, because Docker performs virtualization, and we can run code in a virtualized container that's shielded from the outside world. Also, Docker is very general purpose, as it can run basically anything based on a blueprint that it's given. So we can extend this to other languages like Java, Python, etc., not just JavaScript. Now, let's talk about how we actually run code, and I'll hand that off to Ben.
Thanks, Fred. What happens when you click that play button, and how does that make code results appear? When you click play, our front-end application lets Firestore know this code should be run. Our Node.js Docker client microservice is listening for exactly this input. It takes what's to be run and composes and then archives a blueprint for a containerized environment in which to run your code. This blueprint is streamed out to a separate Docker server. The Docker server extracts configs, creates a container, boots it up, and streams your code. The container emits internal output, and the server streams this out as data. Our Node Docker client is listening for this data, and when it parses something relevant to you, it sends that up to Firestore. Our front-end application is listening for exactly this output. Code comes in, and we pipe the results to you. Meanwhile, server-side, the container is still running, which could be a problem if, say, your code recurses indefinitely. Fortunately, once the container has reached a max duration or your code has finished streaming in, whichever comes first, microservice shuts that puppy down. The buck stops there. But don't take our word for it. Check us out online. We are on devbook.live or on GitHub. We're DevBook. Thank you very much.
All right, to vote for DevBook, like the post, like their pinned comment. I have to say, that was a lot of technologies all come together. And I think I've always loved Docker orchestration projects to run user code in a safe way. I like, you're a nerd.
I mean, I just never trust anyone, and I always love to see what kind of code people want to put into a text box online, but you can't trust it.
Right.
And so Docker is like is the primary solution for that.
Yeah.
I also have seen a lot of Firebase and Fire storage, Fire Cloud this time. So I think it's interesting. I think Firebase, I've not traditionally really considered using them that much for my own personal projects, but I might have to change that after seeing the kind of stuff that students are building.
Yeah. I think one of the biggest takeaways from this like last project, and sort of a lot of the projects we saw today, is like the architectural understanding that these students are walking away with, right? Like they have put together projects that show that beyond the normal tech stack that we teach here, they are able to integrate other technologies to fulfill and complete the correct job using the right tools for the job. And that's something that I'm really impressed with.